Temmen reporting live from the ETP for HPC workshop at ISC in Frankfurt. And we're here with Eric van Hinsbergen from ARM to talk about ARM HPC and the European dimension. So welcome.
Thank you.
Yeah. Can you start a little bit about ARM and yourself?
So ARM is an IP design company. We develop IP for microprocessors. Traditional business was in embedded systems and mobile phones. Almost every mobile phone has ARM IP in it. The company is based in Cambridge, in England.
Yeah.
But we have design centers all over the world. I work at one in Texas. There's one in Sofia, France, and then there's the center in Cambridge. We recently started to expand the markets that we target with our designs to include servers, and as a part of that, target HPC. My background was in HPC. I joined ARM over 5 years ago to help lead the high-performance computing research effort. We started in high-performance computing in Europe with the Mont Blanc project, which continues to be a successful way to expand our knowledge of HPC and improve the software ecosystem for HPC for ARM. We're also involved in government programs in the United States to target their exascale program. And of course, a couple years ago, the Japanese announced that they're also pursuing HPC with ARM designs.
Yeah. That was the Fujitsu, I think.
Correct.
So interesting, interested in that. And to make it clear, so ARM is not producing the processors and the hardware themselves; they just provide the
That's correct.
IP technology.
So ARM as a company doesn't manufacture anything. We provide designs and design services, which we license to silicon providers that make computer chips, and then those are then integrated into the systems. So, as a researcher and as a systems company, we spend a lot of time interacting directly with end users and application developers and so forth, so that we make sure that we understand what we're designing these systems for and designing this IP for, so that we can participate in the co-design and create much more efficient systems.
The Mont Blanc project, I think they just announced that they would make one product or one part commercially available.
That's right. So in portions of the Mont Blanc project, we've partnered with several folks, but one of those has been Atosbol.
Yeah.
And they did early prototypes that were research-only prototypes based on ARM. But now at this conference, they just announced the product based on an ARM processor.
Mm-hmm. Okay, so you mentioned the Mont Blanc project. That's one of the European projects which are developing new technology for HPC and direction of exascale. And we have now here this workshop from HTTP for HPC. So how is ARM positioned into that group?
So ARM has been part of the steering board for ETP for HPC since before I joined the company. Mm-hmm. We are, of course, big believers in development of technology and technology workforce in Europe. We've long been a beneficiary of EU's involvement in improving technology. And so our interests are varied within ETP for HPC, but we absolutely are here to help Europe develop a strong European sourced products, both whether they be silicon design or system designs or software, or in all of these capacities. We're very interested in the development of European industry and high tech.
Okay, so the next phase within this European projects would be things like system demonstrators, which show the capability of future exascale systems. So are you also intended to be involved in that, or?
We are. Through the several years that I've been involved with ARM HPC as a researcher, we've spent a lot of time doing workload analysis and architectural development targeting high-performance computing with ARM. And we've developed a rich amount of knowledge about how we think our partners could develop high-performance computing for ARM to target different applications. And we're really want to be involved in the process to help our partners be successful. Ultimately, some of ARM's revenue comes from licensing, but most of it comes from royalties. And so we're only successful when our partners are successful. And so it's in our best interest that our partners are successful, not just for producing prototypes, obviously, but for producing products. And so we are very interested in the success of our partners.
Yeah, but of course, sometimes you first need prototypes before.
Of course, that is part of the process.
You work together with Fujitsu to expand the IP for HPC with a kind of vector type of possibility. Are there any other HPC extensions?
The scalable vector extensions that we developed in coordination not just with Fujitsu but other industrial partners. And both national laboratories in the US as well as national institutes here in Europe is probably the most significant thing. It was actually a change to the ARM instruction set, a sizable change to the ARM instruction set, specifically targeted at high-performance computing. That's the only thing that's been sort of publicly announced. There are many things in our research pipeline where we continue to work on things to improve efficiency of data movement, synchronization, scalability, and the ability to couple our on-chip interconnects with various forms of off-chip interconnects, like communication networks and so forth. So one thing that has been announced in that area is there's a couple of standards bodies that we're involved in targeting specifically that for high-performance computing and data analytics. One of those technologies is something called C6, which is an interface standard meant to address some of the deficiencies of PCI when you're talking to accelerators or FPGAs or communication networks. And then there's another complementary technology called called Gen Z, which we're also part of that consortium, which is again a high-performance interconnect for talking to a variety of peripherals and memory and so forth. And so both of these technologies are very interesting in high-performance computing because they'll enable our customers to couple ARM processors with accelerators and large-scale systems and interesting memory hierarchies, which are going to be critical for achieving things like exascale.
In Europe, there are now a lot of things happening in the HPC world. So you had this Euro HPC announcement, and you had the announcements from the German ministry earlier this week. And so it seems like there is a refocus or a focus on HPC and a determination to get somewhere in the 2020, 2023 timeframe, something like that. So I guess at ARM you're happy with that, or how do you?
We of course, and I think one of the things that makes me happy about it is when I became interested and involved in HPC earlier in my career, it was about the science that it enables. There's something rewarding about providing tools that lets us expand our knowledge and improve quality of life. And HPC always seemed a path as an engineer and as a scientist that really had a tremendous capability in these areas. And Europe has been one of the few places in the world that has stayed focused on the science
Yeah.
and that this is what HPC is about. It's not about some benchmark number. And so that's something that ARM has always, in our activities in HPC, we've always been very focused on being driven by the actual workloads and the science behind those workloads as opposed to just looking for a benchmark. And I am excited that Europe has started to accelerate their momentum in this area because they've held true
Yeah.
to this goal of science and improving quality of life and improving industry and all of these things, as opposed to just focusing on flops.
Thank you very much for this interview.
Thank you.
Voor Premier Magazine, dit was Ad Emmen Reporting.